I'd like to welcome our first keynote speaker. We have Illia Polosukhin. He is the co-founder of Near, and he will be presenting his talk, Securing the Future Internet with AI. Welcome, Illia.
Okay, thanks everyone for coming. It's great to have an event starting at 12, not at 9, especially on Sunday. So I hope everyone is well rested, especially given it's Brussels, everything closes at 5 p.m. anyway. So let's kick it off. If we have slides loading, I think we have AGI faster than, all right. Then we have AV working. Cool, so for those who are not familiar with me, I originally was an AI researcher. I worked in machine learning space for about 10 years before diving into crypto rabbit hole. And I worked at Google Research on natural language understanding. From my perspective, natural language is where most of the knowledge, of the world knowledge is lying, as well as where we're able to really test the intelligence of the machines we're building. And so I joined Google Research to really make progress there. And it was interesting because we had built really interesting models in 2014 and 15, and we were not able to put them in production because Google has very high latency requirements, and the models we had were too slow. They were trying to read all the search results to do that. And so the Transformers technology, right? The technology that's powering right now, ChatGPT, it's powering Midjourney and Gemini, Llama, etc., was invented really from this challenge where we could not get something in production. We needed something that was able to process lots and lots of documents, lots and lots of language extremely quickly in parallel without blocking on reading every word. And so that's what the work of Attention Zone You Need introduced in 2017. Now, I left Google because I wanted to make progress on not just research, but also putting that into production. And we started Near AI, the AI company, in 2017 that was teaching machines to code. And this is relevant because I think this is one of the most important technologies that humanity can build right now, and I'll explain why. Now, back in 2017 and beginning of 18, there was no scale that we're looking at right now on compute, and obviously we were a small startup, and so we were trying to be smarter. We engaged a lot of students around the world to help us with crowdsourcing data. They were pretty much in China, in Eastern Europe, in Southeast Asia. Some of them didn't have bank accounts. Sending money from US to China or Eastern Europe is also complicated. And so we actually started looking at blockchain as a solution to our own problem. How do we programmatically pay people around the world without needing to overcomplicate things? And that's how Near protocol started. And obviously, fast forwarding now, the most used protocol by number of users. And the way we framed the vision is that we want all people to control their own assets, data, and power of governance, right? And this is not just the Near vision. It's really a broader Web3 space vision that we're trying to put together and align resources across all of the projects that are working in this space. And importantly, it's not just about assets, right? A lot of the blockchain original talk, right, DeFi, et cetera, NFTs as well, were all about assets. But even in 2019, we clearly saw importance of ownership of data, as well as power of governance, power of choice, power of being able to choose your journey, not being able to not be dictated by the centralized providers. Now, the new reality with generative AI is that the big technology companies are accelerating this state where they're amassing more and more power. They have a very direct economy of scale where the more attention you spend on them, the more money they make. The more money they make, the more they can invest into pretty much advancing machine learning models to get you to spend more time, right? It's a very negative flywheel for the users and positive on making revenue for them. It also breaks other business models, right? Now, you don't need to go to search results at Google. You can just get an answer that summarizes all of the articles, right? They're just buying data now from other kind of social networks, pretty much turning them into just a data provider, not a platform itself. Same with publications, we're going to see that all transforming. And obviously all of that breaks trust that we kind of create, because the algorithm, like the most engagement and attention you can get of users if you show kind of different kind of things that enrage you and in turn kind of erode this trust that people have in systems. Now, we're on track for this few major companies to pretty much control all of the humanities intelligence tools, right, if this flywheel continues. And the regulations are not going to be helpful here, right? The regulators will be one way or another engaging directly with these big companies, and these big companies will find a way to really dictate what they want. And especially it will limit what open source and kind of startups are able to do because they don't have resources to comply with this. And we see this already happening, right? There's a kind of a war, like a legal war is unrolling, right, where everybody's suing Google and OpenAI in different ways for data, for monopoly, for everything. And this is going to continue because the current legal framework is not able to really keep up with the generative AI. Like, it is fundamentally different technology. It went from the attention economy to kind of this recombination generative economy, and you need to change the regular framework as well. Now, the problem I wanted to talk about today is actually a little bit different problem. And this lies in the fact that all of our systems, all of our software that's currently now running the world is written by people. And people are not perfect, right? On average, we have 15 to 70 bugs per actually, this is a typo, per 10,000 lines of code. And there's 86 million lines of code in macOS, right? So this is like over 1 million bugs in macOS itself, right? Then you go to the underlying networking stack. You have things that running on switches, etc. Point is, we have a fundamentally broken whole stack of our kind of internet operating systems and browsers and applications we're using. And the bigger problem is that AIs are really good at finding them, right? The LLMs are trained on kind of finding, on the statistical, like looking at all the code, and they're actually pretty good at finding things that are like outliers from the normal statistical distribution. And so they're able to analyze and give you potential vulnerabilities now if you point them at specific code base. And so they will be able to find zero-day vulnerabilities. These vulnerabilities will be exploitable by malicious actors. And this is not the doomsday of AI becoming sentient and attacking us. It's really about the same thing that's been happening where hackers are using advanced tools, but now they can do it at scale. So there's research now on using teams of LLMs pretty much to exploit zero-day vulnerabilities. There's been some research from University of Illinois, but this is kind of generally advancing pretty quickly, right? So this is just to give you an example. You get a bunch of agents that are able to probe for different types of vulnerabilities, and if you kind of pipe them in the right way, you can find like 30 to 60% of the vulnerabilities that exist in a code base that people have found. Now, what I did actually, because I was thinking about this even before I saw this paper, I was like, can I find a vulnerability? And so I went to the security vulnerabilities registry, right? There is a place where all of the issues are reported, and I found something that was like a week ago, right? So it's clearly not in the training data. And so this was a vulnerability in Go compiler that would allow to escalate pretty much permissions on a networking stack. So to give you an potential impact is if you're running a Geth node, right, for Ethereum, and you have an RPC that is only accessible locally, right? Through this vulnerability, you can actually, from remotely, to get access to the RPCs that are only available locally. And some people actually have a private key embedded in that RPC because they use it for maintenance. So you can actually get, quote unquote, root access to your private key in the Geth node through this vulnerability, right? So, small problem. And so obviously, the fact that it's published, it's already patched. So there's a patch, And so I took a code that was before. I took the networking module of Go compiler, and I put it into ChatGPT in this case, and I prompted a little bit, you're a best security engineer, and you know how to find vulnerabilities, and list every function and look at what is the potential issues there. And it literally found exact same vulnerability and explained it and give me a specific IP address that if you put in would actually break into the, through the permission check. So this is just an example of the current state, right? I'm not talking about the future. I'm not talking about, that, like this model is going to evolve. This is a current state where you can use them now. And if you have a proper setup where you can test them at scale, you're able to start breaking software right now. So the core idea here is that we need to rebuild the internet from ground up, right? It sounds a little bit ridiculous, but the reality is we don't actually have an alternative. Like every single line of code that's written so far has bugs, and there's no way for us to actually inspect that and make sure that we know all the bugs. Like even if you had audit, even if you had a bunch of people reviewing it, there's still maybe vulnerabilities that are not covered. And so we need to rebuild the internet from ground up in such a way that we can ensure that it is correct, right? And so this is where kind of the bigger vision we outlined for NEAR of user-owned internet really comes from. It's really combining the Web3 tools that we've been developing for years and years now of user ownership, of cryptographic systems, of incentives, of really connecting people in a different way, as well as user-owned AI to optimize for user ownership, for privacy, and kind of enable customization, right? That's a new internet we're building. But the fundamental part, right, of this vision is not just that, hey, we have new capabilities and new values, but we also need to rebuild the old internet, otherwise it's completely broken. And so how do we do this? Well, we need a cryptographically security. We need formal proving, right? So for those in crypto, you've probably heard of formal proving. This is really, when you're writing code, you're also writing a proof that this code is actually following specific requirements, right? For example, it doesn't lose your tokens, right, when you transfer them. It doesn't, change ownership of any assets without explicit signature of the asset owner, right? So we need a way to actually verify that every single line of code is actually following specific requirements. Now, the cool thing about this is actually it's kind of similar to ZK proofs in the sense that if you have a piece of code that has a formal proof, if you put it in your code base and you have your set of specifications, it will actually not work if there's anything breaking, right? So you don't need to validate yourself the proof for every single submodule. You can actually grab submodules that have proofs and plug them into your system. So this has a very nice properties of composability of code that right now, if you're grabbing an NPM package from internet, you have no idea what kind of vulnerabilities and attack vectors you're actually exposing yourself to. And this is literally all of internet runs on that right now, on just a bunch of NPM packages. And so Web3 is a perfect testing ground for all of this, right? Because we have smart contracts that need to be correct. We have a lot of actually kind of security tooling that's been built already around formal verifications. And we obviously have kind of, in a way, an insurance pool, right? When people are using this smart contract, there's money. So there's enough interest to make sure that these things are correct and not breakable. So this is really where this thing's coming together. And now at NEAR AI, we're specifically working on what we call AI Developer. AI Developer starts with, I want to build a specific application in Web3, and it generates you a specification, right? This is kind of, for those who are not developers, this is kind of the intermediate document that usually your product managers or tech lead would write to explain what product you're trying to build. Now, this is AI generated. You can talk to it, you can refine it, you can tell which features you want to add or remove, and what specific flows it should take. Right? And then it goes and writes a code for you based on the specification directly from AI. This is smart contract, front end, and middleware to connect them. And smart contract then needs to have this formal verification kind of coming with this. Ideally front ends as well, but this is a little bit further down the road. So I just want to finish with this idea that we're kind of at an interesting point in the world, right? We have kind of centralized parties that are developing kind of closed source, closed AI models, which are used to put in front of us to really kind of attract, use our attention to convert to money, right? That's really what these companies are doing. That's their business model. And it's all built on kind of house of cards, right? The number of vulnerabilities that are being found, like there's a new SSH vulnerability that was just found, for example, which gives you a root access to every machine, right? There was somebody trying to sneak in a vulnerability in SSH, in a tar library or in archival library that if that went to mainstream, every SSH would be vulnerable when an attacker attacks with a specific key, right? This is like the world we're living in is there's a constant kind of malicious systems attacking everything. And closed source, by the way, doesn't help. The fact that you're like, oh, my software is closed source, so nobody can attack it. The reality is like the fact we know these things about SSH is because it's open source and there's 10 million people looking at it one way or another, inspecting it. Like the reason why that archival bug was found is because somebody noticed a 20 millisecond delay when they were testing their deployment. 20 millisecond delay, and they're like, oh, something is wrong here, let me debug it. And they found there's a piece of vulnerability code was injected during the archival. So we are in a very weird state where we really need to work hard to not end up in a state where everything is exploited, including us as individuals through these big companies, but as well as our systems in the world, our kind of tech systems through this kind of finding vulnerabilities and exploiting them. And instead we need to build kind of a new internet, right, that is based on cryptography, that's based on formal proofs, on math, and on focusing on the user, right, user-owned internet. So I'll just leave you with that. Hope this is good opening and I didn't scare you too much. But thank you, and keep track of progress on Near AI, on what we're doing, as well as we're going to be, we have this office hours actually on YouTube where we invite both Web3 and Web2 kind of developers and founders to talk about kind of recent advancements in this space. Thank you.